blocks are given masses, they are given velocities. Initially spring is relaxed, write it x equals 0. They are kept on smooth surface. It's asking that maximum elongation of the spring. So where is that maximum elongation compression? I think if you go back in the springs, we have just brought this idea, no? When both the ends of the spring have common velocity, then it is right to have maximum elongation. First, what actually happens here? How to decide that maximum elongation? Now look at the momentum, m2u2. m2 is 2 kg, this is 4. So 8 meter per second is the momentum of this block, initial momentum. What about the block m1? 3 into 2, 6 Newton second. This one, 3 into 2, sorry, 3 into
3 into
6,
6,
this
sir.
will be 18. Wait. No. 3 into 3 6 ja 18. So 18 Newton second will be the momentum of this particular block. Then how to decide in what direction they will move? I think both are having initially in what direction the system is having momentum. Initially the system is having momentum towards right. So therefore at maximum elongation both the blocks must have common velocity in the direction of initial momentum. Okay, this is 18. Okay, this is 8. So the initial momentum is in fact towards right only. So first compression or elongation will occur. The momentum of this is more, you can check it, 3 into 6, 18, 2 into 4, 8. So first compression or elongation, first compression will occur. I can't show the complete this one, so let me show only the so here initially this is u1, this is u2. So first now the spring will undergo compression and this will have some say velocity v21, this will be v11. Okay, this so and what is the state of spring? Spring will undergo compression. Call kx1, kx1. So now finally compression. So maximum compression will occur. At maximum compression both will have common velocity and here show like this, kxm, kxm. Then after maximum compression again compression will come. I'll do one thing, this has A and B will take it, VA1, VB1, both will have common velocity. Now VB2, VA1. Now also it will be compression, KX2, KX2. Now next the sequence will be now after this what will happen is natural length it will come. This will be moving with certain velocity, VA3. Spring is relaxed. Maximum compression. This maximum compression, this one. Spring is lax. Now if you go and check it now, VA3 will be greater than VB3. Sorry, VB3 will be greater than VA3. After this, now it will start elongating. So when elongation, so now VB4, VA4. So elongation means how the spring force will act in this direction. Kx4, I'll write it. Now what do we get? The next part of the thing is the sequence, what will happen is a student has to understand here. And now maximum elongation will occur. Again at maximum elongation, I'm showing the maximum, the elongation, the compression. Spring is relaxed. So now elongation. So this is the maximum elongation. Again, both the ends will move with a common velocity. Now this elongation, the spring will be maximum. I am showing it in this way. Very next moment, the next moment after this, again it will be elongation. Now if you go and check it now, how the spring force is acting in the direction of motion of this block. So definitely velocity of this will become greater than this, or velocity of this will become greater than this. The velocity, you can look at this one. This is the maximum elongation. If you go and check it now, very next moment again immediately it will not come compression, again it will be elongation only. So at maximum elongation or compression, you see that one. I am more interested in this condition. At maximum elongation or compression, both the ends of the spring must have common velocity. So how to calculate this one? So what is the net force acting on the system along x-axis? Just make observation. Everywhere kx2, kx2, kx4, kx4, kxm, kxm, kx1, kx1. So net force acting on system along x-axis is 0. So therefore momentum is conserved. At maximum elongation or compression, both the ends of the spring must have common velocity. Then only that possible. So here first compression will occur, then elongation will take place. Who will determine that one? Which one is having more momentum? Okay, this one. So here it will be kxm, sorry. No. So at maximum elongation this will be, okay, I'll give one more. Very next moment, sir, can you tell what will happen? VB5, VA5. So again this will be elongation, KX5, KX5. Look at this one. But again, if you go and check it, no, VA5 will be greater than VB5. So this is again an elongation. From maximum compression, suddenly it will not come to maximum elongation. First, what is the sequence? Natural length, compression. Compression elongation will determine if this is having more momentum than this, elongation first will occur. This is having more momentum than this. So what do you expect here? First compression. Compression, maximum compression, then compression, relaxed, elongation, maximum elongation, then elongation. Again after this, what you get? Again relaxed. Like that, the sequence will take place. Our question is only to get the maximum elongation or maximum compression. So can we take help of conservation of linear momentum? As you see, the net spring force is 0. So applying conservation of linear momentum, initial momentum m1 u1 plus m2 u2 should be equal to, at maximum elongation or compression, both the blocks will have common velocity. Check this one. Both the blocks will have common velocity. Okay, this is the one thing. Next again, how to calculate that xm? Can we apply conservation of mechanical energy? Because what is the spring force? Spring force is the conservative force. So applying conservation of mechanical energy, so we get this is about the maximum elongation. What is xm? Xm I'll call maximum elongation or compression. Okay, do calculation. later on. Okay, now what about the velocity of center of mass? Okay, center of mass 3 kg, this is 2 kg. So center of mass will lie near to this. Anything will happen to center of mass. Center of mass will continue to move with a common velocity. Because what is the net force acting on system? Will be 0. So therefore anything will happen to center of mass. Center of mass, initially it was having velocity, it will continue to move with the same common velocity. UC, let me write it. What is that UC? How to calculate? UC equal to m1 u1 plus m2 u2 by m1 plus m2, which is nothing but equal to V, no, common velocity. So at maximum elongation compression, the blocks will be moving with velocity of center of mass. This was the conclusion. At maximum elongation compression, the blocks will be moving with velocity of center of mass. Center of mass will continue to move with common velocity, nothing will happen. Now center of mass, will it undergo displacement? As it is, though net force is 0, but center of mass can undergo displacement. Center of mass is here, now it will come here, now it will come here. So continuously center of mass will undergo displacement. So again, net force 0, delta axiom don't put 0, because initially there is a velocity of center of mass is there. So what is actually happening here? Though net force is 0, net force is 0, delta VCM is 0, but delta axiom non-zero. There is a situation like this because the initial velocity is non-zero, and what is the acceleration of center of mass? 0. All the conditions will come into the picture here. Anybody having doubt, you can clarify. A student has to analyze the diagram, not like just mere I'll write some equation. Sir, why momentum is conserved, net force is 0. Why mechanical energy is conserved, spring force is a conservative force, and only that force is what doing work. So therefore, we'll go for conservation of mechanical energy. If this surface is rough, then we cannot conserve mechanical energy, because friction will act into picture. Friction does work. Friction is a non-conservative. So we cannot conserve the momentum of these things.